So let's talk a little bit about ordering real numbers, and at the end I'll talk about absolute value rules. So if you haven't already, I have uploaded a picture of this blank document if you'd like to follow along and not have to copy everything down. Writing is a great learning tool. So here we go, ordering real numbers, and by that I mean coming up with what's greater than the other one. So to do that, to show our ordering, we're going to use the number line and some inequality symbols. So for now, we're just going to use these two inequality symbols over here. And sometimes it's hard to remember which one is which. So in math, we always read left to right. And so the rule I remember is when I get to the pointy part, that's the less than. So this symbol here coming left to right, I get to the pointy part, so this is our less than. And the open part, if I get to the open part, that's the greater than. Okay. And when we go to put this in between our sets of numbers, we want to open to the bigger number and point to the smaller number. Okay? So I've gone ahead and given us a number line here that we're going to use because it's the easiest way to follow the rules. So first off, I'm going to start with one that you absolutely know. So 2 and 3. Is 2 greater than 3 or is 2 less than 3, right? So of course 3 is the bigger number, 2 is the smaller number, so we point at the smaller, open to the bigger. So reading this, we would say 2 is less than, using our less than symbol, 2 is less than 3. Now up here in our number line, even though I know you know it, I'm going to go ahead and mark those. So here's 2 and here's 3. 2 is less than 3. 3 is the bigger number. It's furthest to the right. So the furthest to the right number is the greater number. Okay, so it opens to the 3. Now what if I throw in a decimal, like 2.5? 2.5 and 3. Which one's bigger? And again, you probably know when we stick with positive numbers, even if they're decimals, right, most of us have an intuition on that. So 2.5 is here, 3 is still to the right, 3 is bigger, open to the bigger number. 2.5 is less than 3. All right, now, when we go to the negative side of our number line, over here to the left of 0, negative 2.5 and negative 3. So here's where, right, if you don't have an intuitive sense, it can be helpful to actually plot those numbers on the number line. So negative 3, negative 2.5 is between negative 2 and negative 3. So which one of those numbers is furthest to the right? Right? The negative 2 is the negative 2.5 is the bigger number. So that is what we would open toward. So negative 2.5 is greater than negative 3. So now I have two separate decimals. It's not intuitive to me even. So I go ahead and I think about where they live on a number line. So if I put negative 0.1, so negative 1/10, a tenth of the way between 0 and negative 1, and negative 0.5, so halfway between 0 and negative 1, which one of those numbers is furthest to the right? Whichever number that is the greater number. So again, negative 0.1, negative 1/10 is greater than negative 0.5. All right, so here we go. When we have fractions, sometimes, right, there are some rules that you can use. And frankly, with fractions, sometimes I'll think of pi, as in the edible kind. So would I rather have half a pi or a third of a pi? Well, personally, I would rather have half of a pi because I like pi. So 1/2 is more than 1/3. Okay? So a rule, right, the bigger the denominator, the smaller the fraction, because that's how many, right, slices you've cut up whatever it is you've had into. And so if you cut something into thirds, into 3 equal pieces versus 2 equal pieces, right, each of those 3 equal pieces is going to be smaller than, right, the halves. That might have been too much. So if the numerators are the same, right, the bigger number is the one with the smaller denominator. Here's an example when my denominators are the same, right, they're both sevenths. And in this case, the bigger one is the one with the biggest numerator. So again, right, the denominator tells you how many or what they're sliced into. The numerator tells you how many of those slices you have. So would I rather have 3 slices of a pie cut into sevenths or 2 slices of a pie cut into sevenths, right? The 3/7 is bigger. So same numerators, bigger number is the one with a smaller denominator. Same denominators, biggest one is the one with the biggest numerator. Okay. Again, you could also plot those on the number line. So 1/2, halfway between, 1/3, right, would be over here. So this would be 1/2, and here is 1/3. 1/2 is to the right. That makes it the bigger number where I'm opening toward. All right, so now if they go negative, I'm going to go ahead and plot these because, right, I just want to be sure. So -1/2, right, halfway between. -1/3, so again, right, it's like I would slice this into 3 equal chunks. So one of those would be here. So here's my -1/3 and my -1/2. The -1/3 is furthest to the right, so it is the bigger number. So -1/2 is less than -1/3. Okay. And then again, -2/7 versus -3/7. So imagine I'm cutting from 0 to -1 into 7 pieces. I go 2 of them, and then 1 more for -3 of them. So -2/7 is further to the right. It is the bigger number. Okay, so if you can't tell, so let's say you have 2 fractions and it's not following one of those rules or it's not something you might just know, what you can do is you can convert those fractions into decimals. So I don't know which inequality symbol to put between these 2 numbers. So what I will do is I'm going to use my calculator, which by the way, I really like this one. It is a handy dandy, all-purpose, does most everything any house is going to need. So I just did a division and I'm going to translate each of those into an approximate decimal. So I have 0.48. And then that's 1, and then that's repeating. So I'm going to go ahead and put the bar over that. And now I'm going to do 12/16. So then 12/26. 12 divided by 26. Ooh, 0.461. Oh, and it's not negative, Angela. 0.4615. Okay. So 0.48 or 0.46, which one of those is bigger? Right, 0.48 is bigger. It's the greater number, so that's what we open to, point to the smaller. Okay, so we open to the big, open to the bigger number. Point to the smaller, and bigger means furthest right on the number line. Okay, I'm getting kind of long on my video here, so I just want to follow up with absolute value, last thing. So absolute value, first off, the symbols. These are the 2 short parallel lines. Definition, and it has a couple of definitions. For us, we're just going to stick with a basic one. It means the distance, how far away something is from 0. Distance on the number line. Okay. In practice, so what you might remember from some other time is, right, whatever's inside comes out positive. Okay, so absolute value, so this is what we say when we see the symbols, absolute value of 53. So what we do is we just take what's inside and it comes out positive. So if it starts positive, it stays positive when it comes out. Absolute value of -1/2, again, how far is -1/2 from 0? When it comes out, same exact number, but it's the positive version. Okay, now I'm going to try to mess you up. So here I have this one here. Stay with me. I'm going to say the opposite of. So, or you can say negative. So the opposite of the absolute value of -6. opposite of absolute value of -6. So for order of operations, remember PEMDAS, we're going to do what's inside first. So absolute values are just like parentheses when we're doing PEMDAS. So I would do the absolute value of -6 first. So now I have opposite, that's this minus sign. Absolute value of -6 is +6. So now I have the opposite of 6, or just -6. So even though I just said, I know you're saying, Angela, you just said absolute values always spit out positives. Well, the absolute values did, but then there was this extra minus sign here that came on at the end. Okay, hope that helps.